Okay, this video is going to go through two different types of phylogenetic trees, two different words. Now, again, I haven't ever seen this tested on the exam, but it comes up in your textbook. And so I'm just going to really briefly outline to you the difference between a cladogram and a phylogenetic tree. Now, again, it's not the shape. Yeah, it's not the shape of these. It doesn't matter if you draw your phylogenetic trees as like this, yeah, or like this, or like this. Yeah, that's not what determines if it's a cladogram or a phylogenetic tree. What determines whether or not it's a cladogram or a phylogenetic tree is whether or not it's got a time scale. So if it is a scaled tree, so it has an actual thing at the side here that might say 5 million years ago, 10 million years ago, yeah, anything like that, that makes it a phylogenetic tree because it's showing you time. Whereas a cladogram just shows you relatedness. So a cladogram can show me that a lizard is more closely related to the salmon than it is to the lamprey because they have a more recent common ancestor. Okay, here you've got the chance here. I actually don't like this. I think it's the wrong way round in this picture, so I'm going to cross it off. I think you have these in your books on the bottom of page 8. So can you cross off the part that says rooted trees with unscaled branches, because it actually gives you a scale. Yeah, so these ones are scaled and then the other ones are scaled as well. So they're actually both phylogenetic trees. So you might want to just delete this bit here, and anything with a time scale is going to be a phylogenetic tree. So you might need to pause, go through the diagrams on the bottom of page 8 and the top of page 9. So cladograms, I really like this one. The branch lengths are meaningless. It doesn't matter how long they are. They just show what order species split off from each other. Whereas phylograms or phylogenetic trees will actually show accurate time estimates as to how long it's been since two species diverged from each other. You can also occasionally get really weird ones like this. It doesn't mean there's anything wrong with the tree. It just means that at any given point, you can measure how similar two species are by literally measuring this, yeah? So you can measure how long this is, add it to this, yeah, with a ruler. And you would say they have a longer pathway compared to these two here. So these blue ones are more closely related because they have a more recent common ancestor. Whereas the green ones are less closely related because they have a less recent common ancestor. And there's just a little diagram there if you want to have a look at it. But ultimately, that's all we need to know about cladograms versus phylogenetic trees. Cladograms give us, so this one here is unscaled. So this is a cladogram. It just shows us who's more related. So I would say C and D are more related than A and C. Yeah, because they've branched off closer to each other, but it's no scale. Yeah, so it's an unscaled diagram, whereas a phylogenetic tree is a scaled diagram.